Hey everybody, this is Caleb from Crow Customs. Thanks for watching here in my workshop. I wanted to tell you guys about my crow's nest I've been making for 7 or 8 years now, specifically for Harley or inline Harley Davidson springers. They are all cast, investment casted here in the United States, and everything is American made, and all the bars and everything that I do out of these crow's nests is all made here by me, by hand, one at a time. This is a set of my lane splitters that are in progress that you guys are going to see a how-to on that shortly. This is a non-machine version of the clamp. This is straight out of the cast. This is, again, investment cast. It's heat treated, and then I machine the pinch bolts here, and this is a machine version right here. I sell these unmachined, and then I sell them machined. This is a little display thing I built out of a bent up springer, and what happens is this is the front of the clamp, and that slides down, presses down in there, and you're ready to go. The unique thing about mine, and why in part it took me so long to really perfect the piece, is that on the inside of the clamp, inside here, there's a step, and it's about a 1/4 inch above where your rear legs would be. The idea is that you have ample material for your sleeve, for your 1 inch to go in here, without butting up or slamming up against your rear legs. All of my handlebars, I have a lifetime warranty as long as you own your bike. Not happy with the handlebars, something doesn't work on the handlebars, send it back, and I'll refund you or make you another set. The key to building a set of handlebars is, try to make sure everything's square. Now, you can do a temporary fixture, you can work with clamps. I've built plenty with clamps, like C-clamps and things like that. Just make sure you measure and you have a good solid held down part when you start welding and brazing. Okay, cool. Let's make some handlebars. All right, so here's my main rectangular piece of aluminum with the 1 inch bolted on there that my clamp slides on top of there. And then I have a little spacer that goes in between that keeps that piece flat and square, and that little odd shaped block with a bolt on it that will clamp that all down nice and tight, keeping the clamp nice and square. I'll also use this to put this in my mill as a fixture to hold it down to do any milling or anything like that I need to do on it. Typically I'll run like a 1 inch bit down the center of the clamp or the sleeves, and then hone it with a 1 inch bit, kind of keep it clean, and then chamfer the inside edges. Try to maximize a little bit of space to get some brazing there when I braze it. Now I'll bolt it on my main fixture plate, and then this is the backing piece for the vertical. Backing piece of the fixture for the vertical 1 inch pieces, in this case the lane splitter bars. And what I want is I want a snug fit, but I like to be able to slightly rotate them if I need to, because there's a cope at the top of these guys, and I want to be able to adjust them, get them all nice and tidy before I clamp it all down nice and tight with that particular piece of the fixture right there. You'll have to sand or use turn down the end of the 1 inch a little bit, maybe a thousandth or so, to get that to slide down in there. And here we have sort of a mock-up of those pieces. Now here's a little trick I like to do with putting 2 bends along one piece of round bar, 1 inch stock there. I put some die kim, no extra points for being sloppy. And I'll take a right angle piece of aluminum, lay it flat on there, and I'll put a nice fine scribed mark down the pipe. Then I'll take this over to the bender. I have a scribe mark, and I line that up, and then I do my first bend. These are particular bars are 20 degrees. Then I will reposition for the second bend, and then I'll use that mark that I scribed to line the mark up on that little U-shaped cope piece to hold the bar in there. And I'm pulling it snug, holding it snug, and then clamping it down nice and snug. And then I'll do my second bend. Now you can do this with a Sharpie. You know, I find that for me, when I'm doing these tight little bends, that the scribe mark gives me a little bit more accuracy and hasn't failed me yet. So I'll yank this sucker out of the bender. Dropping tools, no extra points for that. And a nice symmetrical flat piece, no weirdness when you get ready to put it in the fixture and weld it up. So here's a mock-up. I'm just checking for square, checking that everything's level, looking good. And then I'll tack weld the top piece. I have a clamp on this one, a C-clamp. Most of the time this works pretty well. I want to modify the fixture to accommodate that, but I make them at different heights depending on what somebody wants. So this always seems to be, for now, be a little bit more flexible. I can adjust the height however I want. But I'll probably modify the fixture in the future to accommodate that. Always changing stuff and tweaking stuff. I do springers on this fixture too. So there I am, just checking for level, checking everything's kosher, and then I'll plug weld down here. Now plug weld is really a matter of preference. I mean, obviously it's not going to hurt anything. You're going to get extra strength. These bars really don't need plug welds. There's ample material in the sleeve. This is 1-inch 120 wall DOM. As long as you got a really tight braze, you're going to be fine. But this also is another way that you can secure everything in place before you do your braze. I'll plug weld a lot of the other bars that, like my pullbacks, I'll plug weld those. It gets tricky lining those things up and getting them square, so plug welding them helps. You want to make sure you plug weld before you braze. You don't want to braze and then plug weld, because you will compromise the bond, or you'll compromise the braze and the fitting, and then potentially contaminate your weld, your plug weld, and that's nasty. So here it is all tacked up, plug weld, and ready to braze. So what I'm doing here, the brazing, I use a small torch on this. It works really well for this. Gives me a little bit more control. I can see a little bit better. And I'm just spreading the heat around the fitting and trying to get it nice, at least sort of preheated around the joint before I start adding braze. And one of the things I learned about brazing is, seems obvious, but it's all about the heat, right? There's this balance, there's this fine sweet spot of too much heat or not enough heat. So what I do initially is I kind of test where I want to be heat-wise by putting a little bit of braze on the joint, and then running my torch around it until I really start seeing that braze get sucked up into that joint. And then again, constantly moving the torch, spreading things out, spreading the heat around. And then once I see I'm at the right temperature and I get the braze start to really suck into that joint, I'll start spreading the heat around and then refining the movements a little bit. It's hard to really notice that here, but when you're working, once you sort of get used to brazing, there's kind of a flow to it, for lack of a better word. I really enjoy doing it. Now, what I'm also doing is every once in a while you'll see me hit the brazing rod, this flux right there, this flux coated brazing rod with the torch, and I'm just sort of cleaning up all that flux, and just trying to limit the amount of gumminess and crap that goes around the joint. Now, you don't have to braze these, you can weld them. You can TIG weld them, silicone bronze or whatever. Should be more than sufficient. I know a lot of guys do that. I've also silver soldered these. Now if you decide to do silver solder, I definitely would plug weld a couple 3-plug welds for silver solder, because even though silver solder is a very strong joint, especially if you use like 56, it's expensive. It's the other problem. But it's not as strong as braze. It has a melting temperature that's a little lower than braising rod, so just be aware of that. And here I am working the other joint, and again just kind of finding that sweet spot of temperature for braze, touching it a little bit. You can also see how that flux and the heat interact and how much it changes that flame. And then I'll take that braze all the way around. I'm also, when I get some braze in there, I'm carrying the heat down the joint, and to expand it and have some of that, you know, make sure the braze, I get enough braze down into the joint to make a really strong bond. So I'm able to get nearly about 3/4 of the way around these joints to get an ample braze and connection. And then once I have that and it cools down a little bit, I can take it out of the fixture and then put it in a vise and then braze up the little spot on the other side. And then if I need to, I'll put it back in the fixture and anneal it and make everything nice and tight. And here they are brazed together. Before I clean them up, hit them with some files, sanding, do it by hand. Now I got the table turned upside down, bars clamped to the table, and I'm TIGging up the coped connection there. So what I'm doing here is I'm kind of doing a manual pulse weld with my remote pedal. So I back off the heat, give it full amperage when I'm feeding the filler rod. And like anything, it just, you know, takes practice. And here is the bars, all kind of cleaned up. These are all cleaned up using hand files, some flap disc here and there, but mostly hand done with files and sandpaper. And this eventually will be polished and then chromed. And I'm gonna ready to test fit them, mount them in the Springer. Here we are. Slide them down there. Should be a tight little press fit. Tap it in with a little rubber hammer, and good to go. Sitting nice and tight. And well, I hope you enjoyed that. I hope you got some information about how I go about making some bars and the crow's nest. And these are, again, these are my lane splitter bars for inline springers. And thanks for watching.